Let's see how we can use an example of bad roommates to help us better understand Locke-Volterra's model of predation. Here we see Locke-Volterra's model, and with so many equations and trends to remember, it can be a bit overwhelming. So let's focus on the essentials, the isoclines. The isoclines represent our barriers for the growth of our prey and predator populations. Remember, these barriers are created by the existence of the other species. They're not the carrying capacity, unlike other models. For prey, their isocline goes horizontally and represents the value of predators that keep the prey population stable, where their growth is 0. For predators, their isocline runs vertically and represents the number of prey that keep their population stable, with their growth also being 0. To get these lines, we use the following equations. For prey, our Rn value shows our prey growth and subtracts how efficient and how many predators consume the prey population, represented by ANP. For our predators, the BANP value represents the growth and ability of our predators to get food, while also accounting for mortality in the population, represented by MP. Setting both the growth rates and population sizes equal to 0, we get the following isoclines. R over A for prey, and M over BA for predators, which makes sense as predation relies on 3 factors: prey density, predator density, and capture efficiency, which is represented by A in both equations. Let's use this theoretical information and compare it to having a bad roommate for better understanding. Let's say we have 2 roommates, Macy and Katrina. Macy is loud and rowdy, Katrina is quiet and timid, and the two frequently get into disagreements because of how different they are. Thus, they decide to split their spaces up to keep them as isolated from one another as possible. So the house is partitioned based on 2 factors: what spaces Macy wants access and what spaces Katrina wants access. In the end, this leads to the house being segmented into 4 different quadrants. Looks familiar, right? Now, using the house as an analogy to Locke-Volterra's model, let's represent prey and predator growth as the happiness levels from Macy and Katrina within each space of the house, with Macy representing the prey and Katrina representing the predator. Remember, prey population growth is shown from left to right, and predators up and down in this situation. If you were to place Katrina into Macy's room, she would easily become uncomfortable. Overwhelmed by loud noises and crowded spaces, she would quickly become overstimulated and socially drained while Macy would be having the time of her life. So Macy's happiness levels would be growing, while Katrina's would be on the decline. In contrast, if we stick Macy in Katrina's room, it wouldn't take long for this party animal to become bored of how quiet and dull Katrina keeps her space. Katrina, meanwhile, would be basking in silence and taking that time to recollect her thoughts and energy. Here we see Katrina's happiness levels on the rise, and Macy's heading to their downfall. In the kitchen, this is the two's favorite spot in the house, where they can indulge in their favorite practices of eating and cooking. While they may be in the same space, there are at least things there to keep them occupied and content, even if they do have to interact with one another. Thus, we see a mutual increase in the happiness levels of our 2 roommates. And then we come to the dreaded basement. To have to go down there for their laundry is something neither of them enjoy. It's dark, scary, creepy, and musty, and so their happiness levels are both spiraling downwards, just as low as the basement goes. As for the center, let's call this their living room, an unstable place where either roommate could be pushed into any of the 4 areas of the house, bringing an unpredictable outcome to their mood. They want to avoid the space, just for their mood's sake. Taking all of this in, we see that the situation, though not identical, follows the same principles as Locke-Volterra's model of predation, where the pockets of growth are defined based on prey and predator equilibriums. So remember to choose your roommates wisely, unless you want to be dealing with your own predation model.